Hi there, welcome to brilliantmaths.com, where every student has an opportunity to learn and excel in maths. Subscribe to brilliantmaths.com and follow us on all our social media handles, and you'll be on your way to success in maths. Today's lesson is from Brilliant Maths Module 8. Get a copy and let's go to class. Today we'll be looking at functions, quadratic graphs of quadratic functions. What is a function? A function is a relation or a rule which relates the values of one variable quantity to the values of another variable quantity. For example, we have y is equal to x plus 5. So the values of y depends on the values of x. So that when the value of x changes, the value of y also changes. Y is equal to x plus 5 is a linear function. We have y is equal to 2x squared minus 3x plus 7, and that is a quadratic function, an example of a quadratic function. Y is equal to 3x cubed plus 7 is an example of a cubic function. But for today, we'll be looking at quadratic functions of quadratic graphs. The general expression for a quadratic function takes the form ax squared plus bx plus c, where a, b, and c are constants. 1, 2, 3, 4, or 5 as the case may be. The highest power of x in a quadratic function is 2. X to the power 2 will be the highest power of x. Examples of quadratic functions are y is equal to x squared, y is equal to minus x squared. We'll see the difference between the graph of y is equal to x squared and the graph of y is equal to minus x squared. Another example of a quadratic function is y is equal to 3x squared plus 10x minus 8. And yet another example could be y is equal to 2x squared plus x minus 6, and so on. The curve produced when you plot the graph of a quadratic equation is called a parabola. A quadratic graph has an axis of symmetry. That's a line parallel to the y-axis that divides the graph into two. It also has a turning point, and that turning point will either be a minimum point or the maximum point of the graph. Let's try and plot some of these quadratic graphs. In this part of the lesson, we want to learn how to draw quadratic graphs. Plot the following graphs. Y is equal to x squared and y is equal to minus x squared. I'd like to plot both graphs on the same axis. Values of x from minus 4 to plus 4. The first thing you do when you want to plot a graph is to build the table of values based on the equation. Remember that x is the independent variable and y is the dependent variable. That means that the value of y depends on the value of x. So that's the table of value. We need to complete it. Values of x from minus 4 to plus 4. So when x is minus 4, y is equal to x squared. Minus 4 squared will give us 16. Positive 16, because minus times minus is plus. When x is equal to minus 3, the value of y will be 3 squared minus 3 squared, which is 9. When x is equal to minus 2, the value of y is minus 2 squared, which is 4. When x is equal to minus 1, the value of y is positive 1, which is minus 1 squared. Minus 1 squared is equal to positive 1. When x is 0, y is 0. That means that the graph passes through the origin. When x is positive 1, y is also positive 1, because 1 squared is 1. When x is positive 2 squared will give us 4. When x is positive 3 squared is 9. And then when x is positive 4 squared is 16. So now we have the values of y. The highest value of y is positive 16. The lowest value of y is 0. So that will determine the choice of the scale we're going to use. So for me, I would use 1 centimeter to represent 5 units. So that's my 5. That's my positive 5, 10, 15, 20. So my graph falls within that range. Then on the lower axis, that's minus 5, minus 10, minus 15, and minus 20. So I've drawn my axis, and as you can see, I have also labeled my axis. Negative x-axis, positive x-axis, positive y-axis, and negative y-axis. You should always label your axis. So now that we have the values of y, we can plot the points. Each value of x with the corresponding value of y. We have also written out our axis: 0, 5, 10, 15, 20 for y, because the highest value of y is 16. How many small lines do you have between 0 and 5? Count it on your graph sheet so that you can determine what the value of each small line or interval is. I have 10. So 5 divided by 10 will give us half, or 0.5. That means that each interval is equal to 0.5. When x is minus 4, y is 16. So that's 15. So 16 will be 15.5 and 16. So mark it with a little x. When x is minus 3, y is 9. X minus 3, y 9. This is 10. So 2 intervals lower than 10 will be 9. When x is minus 2, y is 4. If this is 5, 4.5, and then 4. That's the point y is equal to 4. When x is minus 1, y is 1. Because 1 squared is 1. It's just 2 small steps after 0. When x is 0, y is 0. So the graph passes through the origin. When x is positive 1, y is also positive 1. When x is positive 2, y is positive 4. So that's 5. And this is 4. When x is positive 3, y is positive 9. If that is 10, this will be 9. And then when x is positive 4, y is positive 16. That's 15, 15.5, and we have 16. So now we have the parabola. Don't join the parabola or the curve with a ruler. Just hold your breath and try to pass through the points. That's a little crooked, so I'd like to correct it. Good. That's better. So that's your parabola. It looks spread out. The reason is because the values of x are wider. 1 centimeter for x is 1 unit, but 1 centimeter for y is 5 units. So imagine that we have a different scale where this is our 1, 2, 3, and 4 for x-axis. I just want to show you something. And this is 1, 2, 3, 4 for positive x-axis. I want to draw the same parabola. So when x is 4, y is 16. So it will be here. When x is, minus 4, minus 3, minus 2, minus 1. When x is minus 3, it's minus 3. Y is 9, and that is 9. When x is minus 2, y is positive 4. When x is minus 1, y is positive 1. x0, y0, same point. X positive 1, y positive 1. X positive 2, y 4. X positive 3, y 9. And x positive 4, y 16. So let's see what the graph looks like this time. So these two graphs are basically the same. The only difference is that for the first one we drew, the values of x were spread out. So it really doesn't matter. So that is the graph of y is equal to x squared. Let's now plot the graph of y is equal to minus x squared. The values are going to be the same integers, but with a negative sign. So when x is minus 4, y will be minus 16, because y is equal to minus x squared. Whatever x squared is, negate it. So x minus 4, I'd like to plot the wide one. X minus 4, y minus 16. So if that is minus 15, minus 16 will be just 2 intervals beneath. When x is minus 3, y will be minus 9. Minus 3, that's minus 10. So this will be minus 9. When x is minus 2, y will be minus 4. Minus 2, minus 4 will be right here. When x is minus 1, y will be 1. When x is 0, y will be 0. When x is 1, y will be 1. When x is 2, y is 4. When x is 3, y is 9. And when x is 4, y is 16. So let's join that. Let's join the points. Hold your breath. Do not use a ruler. So you can see that this is the graph of y is equal to x squared, and this is the graph of y is equal to minus x squared. Try it out. Get a copy of Brilliant Maths Module 8 and do some more work. So next we want to plot the graph of 2x squared plus x minus 6 for minus 3 less than or equal to x less than or equal to 3. It's a little more complicated than the graph of y is equal to x squared. Before you plot your graph, build or compute the table of values. You need to pay attention so that you will get the correct values for y. So first, on your table, write out the values of x from minus 3 to plus 3. So when x is minus 3, when x is minus 2, minus 1, and then finally when x is 3. Then on the next table, we want to compute the value of 2x squared for each value of x. So we have 2x squared. So when x is minus 3, x squared is minus 3 squared, which is 9. And then 2x squared will be 18. When x is minus 2, x squared will be 4. And then 4 times 2 is 8. When x is minus 1, x squared is 1 times 2. When x is 0, 2x squared will be 0. When x is 1, 2x squared is 2. When x is 2, 2x squared will be 8. And when x is 3, 2x squared, 3 squared is 9, 9 times 2 is 18. So we have the values of 2x squared. So next is plus x. So the values of x are minus 3, minus 2, minus 1, 0, 1, 2, 3. And then the next step will be minus 6, to take away 6. So minus 6. So we're going to subtract 6. So having done that, we're now going to compute 2x squared plus x minus 6 to get the value of y for each value of x. So we have 18 minus 3 minus 6. Minus 3 minus 6 is 9. So 18 minus 9 is 9. So that means that when x is minus 3, y is equal to 9. Next, when x is minus 2, 2x squared plus x minus 6 will be 8 minus 2 minus 6. Minus 2 minus 6 is minus 8. So 8 minus 8 will be 0. When x is minus 1, 2x squared plus x minus 6 will be 2 minus 7. Because minus 6 minus 1 is minus 7. So 2 minus 7 will be minus 5. When x is 0, y will be minus 6. When x is 1, 2 plus 1 is 3. 3 minus 6 will be minus 3. When x is 2, 2x squared plus x minus 6 will be 8 plus 2, which is 10. 10 minus 6, which is 4. So when x is 3, y will be 18 plus 3, which is 21. 21 minus 6 is 15. So the next task will be to draw your x-axis and y-axis. Choose your scale and then plot the points. Where x is minus 3, y will be 9. When x is minus 2, y will be 0. When x is minus 1, y is minus 5. When x is 0, y is minus 6. When x is 1, y is minus 3. When x is 2, y is 4. And when x is 3, y is 15. Let's try that out. From the table of values that we have, we can see that when x is minus 3, y is 9. So we'll plot that point. When x is minus 2, y is 0. When x is minus 1, y is minus 5. When x is 0, y is minus 6. And then when x is minus 1, y is minus 3. And when x is 2, y is 4. When x is positive 3, y is 15. So you plot those points on the axis. And this is what we have. Remember that coordinates are ordered pairs. X coordinate comes before y coordinate. As you can see, this point is x minus 3 and y 9. That is different from x 9 and y minus 3. So please take note of the order. X comes before y. And once you have plotted your points, hold your breath and join the center of the points. To draw your curve. Yes, you have something like that. So this is the graph of the function f of x is equal to 2x squared plus x minus 6. The solution of this graph is at the point where the graph intersects the x-axis. Assuming we are told to solve graphically, f of x is equal to 2x squared plus x minus 6. The graphical solution are the values of x where the graph or the curve intersects the x-axis. And then the minimum point, this is a graph that has a minimum point. The minimum point is the lowest value of the graph. And the axis of symmetry is midway between the solution points, halfway between minus 2 and 1.5. We'll be looking at that in the next lesson. Next, we want to look at turning point and axis of symmetry. The turning point is a point on the graph that the parabola changes direction. So for example, the first graph we have here, the graph was going down, sloping downwards, and then suddenly it starts going up. So that is the turning point, where it turns from going down to going up. And in this graph is a minimum point. But what determines whether or not it's minimum or maximum is when the coefficient of the quadratic term, the coefficient of the quadratic term is what determines whether you have a minimum point or a maximum point. When the coefficient of the quadratic term is positive, then you have a parabola that opens up that looks like a cup. So it has a minimum point. In the second graph we have here, That's the turning point. The graph was going up and then suddenly it starts coming down. That's the turning point, and the turning point is a maximum point. And it's a maximum point when the coefficient of the quadratic term is negative. The coefficient of the quadratic term is negative, and then you have a maximum point. The turning point is the maximum point there. For axis of symmetry, the axis of symmetry is the line that divides the parabola into two. You determine that line by finding the midpoint of the solutions. Remember we said that the solution to any quadratic graph are the points where the graph intersects the x-axis. So those 2 points are the solutions of the graph. Then you find the midpoint of those two graphs. The x-coordinate of that point is the axis of symmetry. So you find that axis, and that point, that line or the axis of symmetry is parallel to the y-axis. So in this case, let's assume that this point is -1, and the point we have here is 4. So how many steps do we have from -1 to 4? We have -1, 0, and 4. We have 5 steps. So half of 5 is 2.5. So the line of symmetry or axis of symmetry will be at the point where x is equal to 2.5. So the line x equal 2.5 is parallel to the y-axis, and that will be the axis of symmetry for this parabola. Let's look at one more example. On your screen, you can see the graph of y is equal to minus 2x squared minus 4x plus 3. It's a parabola that opens downwards. The coefficient of the quadratic term is -2. So it opens downwards. So it has a maximum point. You can see the maximum point there. At the maximum point, the coordinate of x is -1, and the coordinate of y is 5. What is the line of symmetry? The axis of symmetry for that parabola is the line x is equal to -1. As you can see, that line divides the parabola into 2 equal halves. Note that the line of symmetry is a line that divides the graph into 2 equal parts. So from the graph above, the line of symmetry is a line that passes through -1 on the x-axis. Therefore, the equation of the line of symmetry is x equal to -1, and that line is parallel to the y-axis. You can also note that the parabola above is maximum. Therefore, the maximum point is -1, 5. And the maximum value of the graph is 5. That is y is equal to 5. You can see the turning point, and we can also see the axis of symmetry. So look at the next example on your screen. We have the graph of y is equal to 2x squared minus 12x plus 11. In that function, you can see that the coefficient of the quadratic term is +2. So it's a parabola that opens upwards, that looks like a cup. The axis of symmetry is at 3. The solutions of the graph is at x equal to 1 and x equal to 5. So what is halfway between 1 and 5? 1 plus 5 is 6. 6 divided by 2 is 3. So the line x is equal to 3 is the axis of symmetry. And then what's the turning point? The turning point is a minimum point. The graph has a minimum value at y equals to -7. So the minimum point is x equal to 3 and y equals -7. While the line of symmetry or axis of symmetry for that quadratic function is the line x is equal to 3. For more of this, get a copy of Brilliant Maths Module 8. I hope you enjoyed all the lessons on quadratic functions, drawing a quadratic graph, the parabola, finding the turning point, the axis of symmetry, and so on. Subscribe to brilliantmaths.com. You'll be glad you did. Follow us on all our social media handles. And for quadratic functions, get a copy of Brilliant Maths Module 8. My name is Ngozi Orevogene, and always remember that maths is fun and you can excel in it.